Hello everyone, and welcome back to this next video in the Houdini Academy Foundation module. In this video, we are going to continue where we left off last time and start working on the collision system for our FBX models. Now, in the last video, we made sure that we could output our FBX models either as complete models or as instances, and then also assigned the material to them so that we actually have fully generated models from their original source FBX files inside our building right here. Now in this video we need to assign some collision to these as well. So that's what we'll be working on next. And for that I need to go to some slides in order to explain to you first the different kinds of collisions that we'll be able to add to our tool in order for it to be supported in Unreal. Okay, so the first type of collision that I want to discuss is the simple collision type. And this one creates a simple convex collision box around your object that only has a limited amount of facets. We have some limited control over what type of faceting it's going to use based on some different naming convention, but the simplest way of defining it is by simply creating a primitive group on your geometry on all the pieces that you want to have included in this collision, named collision_geo_simple, and this will generate automatically in Unreal a simple collision mesh for that object. Now, like I said, this collision is convex, so if you have any concave shapes like a U shape or an L-shaped building, then you will need multiple simple collisions for this entire object to be covered. In this case you can see that there are some definite concave shapes on this rubber toy, and it just creates an entire volume around it, right? Now, the benefit of simple collisions is that they are cheap. They are good for physics because they're very lightweight, so you can actually use this as a physics object, but they are not very accurate. Now, next to this we have UCX collision. And UCX collision works in the same way as a simple collision type. You simply have to create a primitive group called collision_geo_UCX, and it will generate it for you. Now this collision is also convex, and likewise we also need to have multiple UCX collisions in order to cover a concave model. And finally, this particular collision type is actually the default collision type that is stored inside FBX files. Now in the foundation module I am not going to export FBX files from Houdini. We'll cover that in a later module of the masterclass. However, you can actually do this in a roundabout way by taking a mesh that the Houdini Engine has generated and then baking it out to an actual static mesh, and if this one came with collisions or materials, that will also be assigned. And then we can take that baked out mesh and then we can export it back out to an FBX file, which will have the proper UCX collisions assigned. I'll quickly show you what I mean with that, but then we'll move on with the slides. So over here in Unreal, if we take my example building, which already has collisions assigned, and we look at one of the output models, like for example one of the instances that we generated on the roof, this one, then you can see that it comes with, in this case, a convex collision type. Okay, we can even scroll down here and look at this actual collision settings, and we can see that it has a convex element right here, and this basically describes our current convex collision box. Okay, this is the UCX collision that I'm talking about. Then we can go and find this mesh inside of the temporary folder right there. We can also click on this and then actually bake it out, and this will then put it inside of the Houdini Engine bake folder, which is all the outputs that I've generated in this scene from Houdini. We can then right click on that mesh, go to Asset Actions, and then click on Export. And when you do this, you basically have the ability to export it directly out to an FBX file, which I already did right here actually. We can save that out. We'll bring up this dialog and it will ask you, do you want to include collisions? And if we do that and we export, then now we can actually import this mesh into Houdini again, and it will have collisions come along with it. So let's browse for that. Should be this one. There we go. So now we have over here a mesh with, again, UCX collisions. And these were just generated by the Houdini engine. We took that model and then we exported it back out. Now let's go back to the slides and I'll continue with the last set of collisions and I'll explain a bit more in detail what they actually do. So let's open those back up again. Now the next type of collision that I want to discuss is the complex collision, which I already covered when we made our building, right? So this one uses the collision underscore geo primitive group in order to assign it as a complex as simple collision. And next to that, complex as simple collisions can only be used for static raycast type collisions. They cannot be used for physics objects, such as movable physics objects. They're too complex for that. Now, there's two ways to define a complex collision, and the better way is to use a low resolution secondary collision mesh instead of using the actual source mesh. Now, in our case, we have already dealt with this when we were creating our building, and we have our complex mesh, which has all these bevels, right? If we look at that, we have all these little beveled edges over here that the player has some trouble with stepping up on. And the same thing will apply when we're dealing with steps later on in the staircases. So to deal with that, we created a dedicated collision mesh, which is a lot more lower resolution, so the player doesn't have issues with it. That's what I mean with the secondary collision mesh, with the collision geo primitive group, in order to make sure that this works properly. So it isn't too heavy for the engine and it's easy enough for the player character to navigate. Let's go back. And then last, I'll just quickly cover packed geometry again, because this has its own benefits. So packed geometry, when we create it, is going to be evaluated as a separate mesh in Unreal by the Houdini engine. So if you create a packed geometry on your mesh, then by default it's going to split it out as a separate mesh. However, if you create copies of that packed geometry, then it will output it as an instancer with instances instead. So that's actually a nice trick you can do with packed geometry. You can either use it to split your geometry going out of a same output into multiple separate geometry objects in Unreal, or you can turn it into an instancer immediately by just making copies of the packed geometry in Houdini and then outputting multiple of those at the same time to Unreal. And like I mentioned, everything that we provide to a packed geometry will be part of the same mesh output in Unreal, and that includes collisions. So therefore, inside of a packed geometry, all other collision group rules apply. So we could still use any of the other types of collisions and they will still work. We could create packed geometry which has complex collision. We can use it with simple or UCX collisions. Both of those work, but basically packed geometry will just split whatever you're outputting into different pieces, either as separate pieces of geometry or as instances, depending on if you copied it or not. Now, before I continue, let me quickly go a little bit more in depth and explain the different types of ways how we can use collision groups inside of Houdini to define collisions in Unreal, and how this also relates to packed geometry, because there are different ways how we can combine this and it will output different results. So knowing how to combine it properly means that when I go ahead and build this in a moment, to have a better idea on what's going on so you won't be lost. So the first type of collision here is again the simple collision type, which is lightweight, convex only, and supports physics. And there are two ways how we can define this type of collision. We can use the simple collision geo simple tag, so this is a primitive group, or we can use the rendered collision geo simple primitive group. And these two have two different effects, but they're very similar to what we already did before with the complex collision type. Basically, if you define a collision underscore geo underscore simple, you need to provide it on a secondary mesh, which is going to decide what the shape of the collision is going to be for your main mesh. And then next to that, we have our rendered collision geosimple, which if you provide that to your main model, is simply going to turn that part of the model into a collision mesh, right? So that's the simple part. Now, if we go a little bit more in depth on this, then by default, if we try to apply any of these two to this type of model, so we have 4 different toys combined in the same model output, we're simply going to generate one giant collision volume around them. So that's not very good, right? We won't be able to walk between them, and their collision is just not accurate at all. Now we could actually split this up by splitting the groups into separate groups. And if you use the rendered collision geosimple and you add an underscore and then say a number behind it, then it will create separate models, separate model outputs for every single collision that you're assigning, which does mean that every single model will have its own collision, so they won't be combined like up here, but they will be output as separate models altogether. And that just means that we're basically just generating, I don't know how many models for our scene, which is not good either, right? Now the best way to do this is to use a secondary collision mesh or multiple secondary collision meshes, and then have each one of those assigned its own index, its own postfix number, so like here. And what this will do is that every single model has its own collision, its own secondary collision mesh, with its own group and its own number for that group, and then it will just output it as a single model, but with 4 separated collision objects. Now the same thing applies for UCX collision. If we take this, which is again a form-fitting, convex-only collision type that supports physics, but if we take these and we apply the same rules, then the same thing will happen. We can have our combined collision, which doesn't look very good. We can have our split models using the rendered collision type, which again is not really desirable. And then finally, we have the collision underscore geo underscore UCX underscore whatever name or number you want to give it. And as long as these are unique, it will create a unique collision model in the UCX type for that. And this will also work this way if you want to import it into Unreal from an FBX file. Now the last type of collision, complex collision, basically is a per polygon collision, which could have an optional secondary mesh. Now we've already gone over this a few times, so I won't hammer on it too much. But basically, if you combine a separate collision object with the collision underscore geo primitive group with the main model, then you get this result, where you have the main model with a complex collision type from the secondary model. Now in this case, you do need to have 2 different models to make this work. The other types of collisions don't need this. They have their collisions baked into the single model itself, right? You only need 1 Unreal model for that, 1 static mesh. But for complex collisions, you will need 2. On the other hand though, if we're using the rendered collision geo, like before, you only need 1, but it will just take the current vertices and the current primitives from this model and use it as your collision. Now, like I mentioned, right now there is a bug in Houdini 18.5.596 that will take whatever geometry you have that doesn't have a collision group of some kind assigned to it, and it will automatically set it to the rendered collision type, so complex as simple collision. And that just means that whatever geometry you have will automatically have collision in Unreal. I expect this bug to be fixed in the future, but it's easy to bypass. As long as you have some other kind of collision assigned to your geometry, this bug won't happen. But yeah, if you want to use a complex collision geometry, then I suggest that you use collision underscore geo, create a secondary mesh with that group, and then assign it to your original mesh. And in this case, you can't actually use a postfix number because as far as I'm aware, you can only assign 1 collision mesh per model anyway. So this will do. Now the way how you go about using the rendered collision geo versus the standard collision geo, basically, if you're using a rendered collision geo, like I mentioned, you don't need to do anything else. You just need to assign it to whatever visible mesh you have. And if it's a simple, a UCX, or a complex type, this will just assign it to whatever mesh you have and it will work. On the other hand, if you want to use collision underscore geo, so the separate collision mesh, then you need to provide it like this, where you have one mesh or your visible mesh, and then a separate collision geometry next to it in the same merge node, in the same output. Now, in case you're using collision groups with numbers, then for every collision group that you have, so 1, 2, 3, and 4, it's going to create a unique collision object per mesh. And like I've already shown, if you're using the rendered collision geo and then a number behind it, it will create multiple meshes, one for each collision geometry group. So keep that in mind. Now in the case of packed geometry, this works slightly different. Let's say that we add a collision group to an object and then we pack it and then we duplicate it. Well, for the simple collision type, this is what would happen. Let's say we have this model here. This is one packed geo, and we just duplicate it. And all this really will do is just create instances of that model with that collision on it. So in this case, as long as we provide whatever collision information we have to this model, it will work. And this will also work with any numbered collision groups as well. So you can even have multiple collision groups on this, have multiple sets of simple collision for this model, and it will just duplicate that for every instance. The same thing's true for UCX collision. So if we have that, it will apply it per instance. And finally, we can even do this for packed geometry with standard complex collision. However, there is a bug I've noticed where it generates an additional second instancer for the collision geometry as well. And we can easily filter this one out if you bake out the mesh and then you throw away that particular instance component. But it is a bit annoying because, well, it shouldn't even be there, right? So let's go back to Houdini and let's start building this system. Okay, so over here in our loop, we need to start working on adding a bit more support for our different collision groups. So I suggest that we start with the single collision assignments, that being the collision here, this type, where we just have either rendered collision geo or collision geo. And that will, of course, for the simple type, just combine everything together. But of course, if we go and pack our data using our packed instances, which means that we turn on the copy to points node, then anything that goes into the copy to points node will be instanced anyway. So whatever collision we assign here at that point is simply going to act like this, right? Where we have one model with its collision and that just gets copied. So at that point, we don't need to worry about any numbering behind the groups. It will just work. So let's get started on this, and then we'll work on the numbering system after. Over here, inside of my control panel, I want to add a new ordered menu, specifically for the type of collision that we want to assign to our model inside this loop. The first one is going to be a complex collision. That's basically going to come from our current collision inside of our FBX file. Then we're also going to create a simple and a UCX collision from the actual model itself. And because this is going to be inside of this loop, this will either be, if it is set to simple copy mode, for the entire model or all of its copies. And if it is set to instance mode, it will be for the individual instances, like we just discussed. So let's get started on that, and let's open up the type properties. So in here, let's scroll down, and I'm going to add a new parameter in here for a switch. Let's first work on the parameter. So let's add a new ordered menu, and I'm going to name this one Unreal Collision for FBX. As for its label, let's say FBX collision for Unreal. Okay. And just like before, this should be disabled when it is not set to export FBX output. So over here, let's grab our props output mode is less than 3. And let's paste it into our new parameter. Like that. And then let's go over to the menu tab. And in here, I want to add 4 entries. The first one is going to be 0 for no collision. And that will be in case we simply don't want to assign a collision group at all. Then the next one is going to be called 1 FBX sourced complex collision. Okay, so in this case, it's going to grab the collision from our FBX file and it's going to turn it into a new complex collision. And then the next entry is going to be number 2, and this will be a new simple collision. And then the final one is going to be a new UCX convex collision. And as for its default value, I'm going to go over to my channels and I'm going to set this to 1 because by default I actually wanted to use the sourced collision from the FBX file if possible. So that should be value 1. Okay, so let's accept this. And now we have a new control right here that we can grab from. So let's go ahead and set this up. Down here, I'm going to add a new switch. And I'm going to plug it in. I'm going to call this the Unreal Collision for FBX switch. Okay. Let's grab the setting from here on the right. And let's paste it in here. So we have direct control over that. And then let's go ahead and set up our various types of collisions. So like I said, the first one is going to be the collision that's currently present on our FBX file. So if we look a little closer at that, you can see that right now we are filtering it out here on the left. So just grab that, copy it, and invert it, right? So I'm going to say, instead of remove, isolate. And then I'm going to flip this to delete non-selected. So that should keep all the UCX collisions currently present on this mesh. And then let's go and grab these two from here on the left. Grab that, copy it. So we need to remove all of our attributes, so our UVs and normal too. So that will create a clean piece of geometry for our collision. And then this one will deal with the scaling, of course. Basically scale it back down to 0.01. Then let's give it a new normal. So over here on the left, I'm going to grab this normal node. So as this will get combined with another mesh, I want to make sure that it has a normal assigned, so it doesn't look black. Alright, so this should work. And then finally, let's give it a group for the collision type. So in this case, this is going to take the UCX collision on our FBX and it's going to turn it into a complex collision mesh. So let's call this one collision from FBX to complex. And then in here, I'm going to call this collision geo. So that's going to be the collision geometry for the complex collision. And we're going to have to pair that with our actual geometry over here. Otherwise it won't work. So with this set up, give it a color and let's plug it in. So we need to grab a merge node over here. Grab the original mesh, this one. Then grab the collision mesh. plug those together, and let's rename this one include complex FBX collision. Okay, so that's going to be our first actual collision entry, or the second entry for the switch. Then let's go ahead and add the rendered collision geo simple that we'll need. So let's grab this collision node up here, copy it. I'm going to plug it into our output here for this switch. And I'm going to rename this one to rendered collision geo simple, so the actual group name. Let's copy that and let's plug it up here. So that should be correct. Let's plug that into our switch over there. And then let's do the same thing again. Let's copy this. And let's rename this one to UCX. So all lowercase, simple should become UCX. Let's plug that in as well. Now I might not need to actually move everything so far over to the right, so let's just grab it, move it a little closer. Okay. And now we should have control over what collision is going to come out of our loop. Alright. So with this, we can now switch between our FBX sourced complex collision, our new simple collision geometry, or our new UCX convex collision geometry, or just no collision at all. Alright, so let's go ahead and make sure this is being output and we can test it. So down here, I'm going to add a couple of cleaning groups just to make sure that whatever comes out of this network is clean and proper. Let's go over to the left here, and I want to grab this particular clean attributes node. Copy that, paste it down here, and then I want to add one more thing here to the primitive attributes, because in case we are actually outputting our FBX copy geometry and we are outputting our materials, then over here we will actually have our Unreal material primitive attribute. So that one we need to keep as well, right? Let's go over here and let's filter that one out. Make sure you add the hat symbol in front of it, and that should set that one up. And then let's also add a group delete node. Let's copy from here on the left, this one. I'm going to add this one here, and in this case I want to delete all groups except for rendered collision geometry with an asterisk behind it, because we do have different types of rendered collision geo, like the simple and the UCX collision. And then the same thing for our collision geo here. Let's also add an asterisk to that. So with that, this one should be set up. Let's also make sure we have an output group specifically for this mesh. So I'm going to go over here to the right, grab my mesh visualizer group, and I'm just going to plug it in down below. I like to do this because if I ever need to take this data out of this tool, then I at least know which one of this is which. Okay. So with that, we should be ready. Let's go over to the end of the network. Save this out. And let's load it into Unreal. So re-import, rebuild. So now we should have some collision assigned to our models. And you can actually see that we do have some doubled up collision. Now I think this is because right now it is set to packed instances in combination with our complex collision. And if you recall, if you do that, there's this bug right? So if we just quickly look at the slides again, then it will actually double up your instancers and create a second instancer with the collision geometry. Now this isn't a big problem because we can go ahead and filter that out, but it is a bit of a nuisance. Like here you can see we actually have 2 instancers, but besides that, let's go ahead and test out the rest of the tool. So let's switch it over to copied geometry instead. And now we should actually have a collision mesh with our vents. Here we go. So this is going to be the collision mesh for our vents, for every vent. And then here's the actual model with the collision mesh assigned right there. So this thing does have collision. If we look at the complex collision, here we go. So that's the actual collision mesh being used on this model. That's working. Then further down, we also have simple collision. Now by default, if you apply this to the entire set of meshes, and we're actually going to look at the collision right now, then you'll see that everything gets added in one giant collision box. And that's simply because we aren't splitting this collision for every single model, right? We are basically just combining them all together and then creating one single rendered simple collision out of that. So we still actually need to address that. We'll do that in a minute. But if we set this to instances, however, then inside of our models down here, we should now have a dedicated collision for this model as a simple type. So this will then work for the instances. So every single instance here has its own simple collision. Now let's switch this over to a UCX collision. And now if we look at it, and we look at the simple collision again, now you can see now it's using the convex UCX collision for this model, and that then gets instanced onto our building. So all of this should be working. In fact, we can actually test this out if you want. Let's grab this character, let's drop him on the building. So let's quickly test this out. Let's say I jump onto one of these vents here, and if we look below the feet of the player, we can see that on the right side of the vent we can stand on pretty much the surface, but the moment I walk towards the left, I'm starting to float. And that's actually because our collision mesh, our UCX collision that's being generated from the shape of this vent, is causing us to walk up into the air a bit. And that's directly related to the way how the collision is shaped on these vents, right? The convex bounding box has that shape because of that. So with that, we can pretty much say that our current collision system is working, but we still need to make sure that we deal with it when it's actually set to copied geometry and we have these other types of collisions. Because right now, even with the UCX collision, you can see that we have the entire vent set enclosed into one collision mesh. And I don't want that. I want each one of these to have its own dedicated collision. And the only way how we're going to be able to do that is by splitting our collision groups. So let's have a look into that next. Over here, inside of our network, what I want to do is add an additional option that will allow us to split our geometry groups. Basically, these ones, collision geo, or in case of the convex collision, this one, rendered collision geo UCX. I want to change that to collision geo UCX underscore 0, 1, 2, 3, etc. based on the amount of objects. And to do that, we need to first create a new control here on the right, and also add a unique identifier to every single object so we can give each object its own collision. Let's do that first. Over here, let's open up the type properties again. Let's go down. And I want to add another ordered menu here. Let's grab one from the menu on the left, like so. I'm going to name this one the convex Unreal collision for FBX. As for its name, let's call this the FBX convex collision type. Alright. Then under the menu options, I'm going to set the first entry to 0, and this is going to be the single shared collision. So that's going to be in case we basically have this, right? Where we have all of our models combined into one collision volume. So that's fine. Then for the next entry, number 1, let's call this one multiple collisions per object. Okay, so that's in case we have the collision geo underscore and then the number. So that one will assign to a separate collision mesh that will then be combined with the original one. And then the last one, number 2, is going to be unique objects, or unique object for every collision. So in that case, we are using the rendered collision type, but with a postfix number. Okay. Now I don't want this to be exposed unless certain conditions are met, just like before. So I want this to only be available when we are in FBX copied geometry mode, because we don't need it for our instances and we don't need it for our FBX instances either. So this is going to be number 3. Let's copy this entry from here. And I'm going to change this to if it is not equal, so exclamation mark equals, to 3. So if it is not that, then this is disabled. And then I also want to add that it will also be disabled if the collision type is anything below 2. So anything below these two here. If it is the complex collision or no collision at all, in which case we don't need this either. So in that case, we're going to shut it down as well. Let's grab the Unreal collision for FBX. Move over here and let's add a new bracket set. This means that there's a second condition, and if this one's true, basically it's an OR condition. If this is true or if that is true, then we are simply going to hide this as well. So if it is less than 2, if it is less than the second entry, then we'll hide this one. And then let's just make sure we set up our default value as well. So under our menu items, I would like to set this to multiple collisions per object, because that's the desired type of collision, right, for these FBX meshes, to have potentially multiple collision objects per mesh assigned properly. So in the channels, I'm going to set this to 1. Okay, so let's apply this. And then what I do want to do is I want to move this one over behind this option here. Now in Unreal this won't work, but in Houdini it just makes our option a little bit cleaner. So inside of these settings, I'm going to grab the FBX collision for Unreal. I'm going to click on horizontally join the next parameter. If I do that and I apply it, then it's actually going to take both of these parameters and it's going to join them next to one another. But I don't actually want to have this name here exposed. So I can then take the label for our FBX convex collision type and turn it off. Now in Unreal, this will actually be visible, but in Houdini it won't. So if I now apply this, it's going to hide our label inside of Houdini. But the moment we bring this into Unreal, it will still be there. Just something to note. Not every one of the menu options that we can do here in Houdini will translate properly to Unreal, and this is one of them. Okay, so with that set up, next we need to add that unique identifier for every one of these objects. And to do that, I'm going to simply add a attribute create node to the top here above my loop and give it a unique object ID before we feed it through the loop. So let's create an attribute create node here. You can simply type create, which will usually just grab it. And then let's type object ID. Set that up here in our parameters as well. So object ID is going to be an integer point, and then we'll use the local variable pt to grab our current point. So if we just look at this one, we have all these points here. They have their own point attributes, and over here on the right we should have object ID, which corresponds to their point number. So every one of our events is going to have its own ID. Now this will work for propagating through our network. If we go down to the bottom and we click on the info panel and we look for this attribute, we will see that we do get now a unique attribute for every single one of our meshes, because our copy to points node is transferring this to a point attribute. But I cannot use a loop over a point attribute, because if I use a point loop like this one, it will only output points. And I'll show you what I mean. Let me quickly create a for each loop that runs over points. If I plug that in, then it will only output points. And I don't want that. I need to keep my primitives, right? I need my meshes. So what we need to do is actually promote this point attribute to a primitive attribute before we create a primitive loop. Now we can actually do this on our copy to points node. Instead of copying directly the attribute, which it would normally do right here because of this asterisk symbol inside of the first line of the copy behavior, I want to add a new entry here. I want to set this to primitives, and then I want to say copy the object ID. And what that will now do is it will take whatever object ID it finds as a point attribute, and then it will apply it to the primitives of whatever it has copied. Now in this case, what this means is that if we look at the output of our loop and we look under the primitives here, we now have our object ID being assigned to our FBX meshes. Now if this was set to instances, it would actually still work, because our instances actually contain all three types of element objects here. We have points, we have primitives, and we have vertices for every single packed geometry. This is a way for packed geometry to store these types of attributes, even though technically they don't have that. They technically have a point, but that point actually also doubles as a primitive and as a vertex as well. So it can store all three types of data, which is actually quite interesting. But it's also beside the point, because we don't actually need to carry over this attribute when we're dealing with packed instances. We only need it for our FBX copies. So let's switch that back over. And then let's set up a little loop over here that runs over primitives, so we can adjust the group names to have numbers for each one of these individual meshes. Create a for each loop that runs over primitives. And let's plug that in. And let's set this up so it runs over the piece attribute over here for the object ID. So now, if I go ahead and look at single pass, we should be getting one mesh each. Okay, so that's good, that's working. Then next, let's make sure we set this name up as well, quickly. Okay, keep it nice and organized. And in this case, what I would like to do is set up this loop so it deletes the original collision geometry that is present on these meshes, no matter what it is. okay, because I want to replace it. I don't want to keep the old one around. So let's create a group delete node first. This one's going to clean the collision geo. And under here, I'm just going to remove the rendered collision geo. And then no matter what it is, simple or UCX, we're going to remove it. Okay. So now we no longer have that collision geometry around. And then what I want to do is I want to recreate a new group using a wrangle node. So let's go ahead and do that. Let's go ahead and create an attribute wrangle node here. And I'm going to plug this in. And I'll name this one collision geosimple. This one's going to assign a numbered collision geosimple for us. Then over here inside of our code, the first thing that I need to get is the current object ID. So let's first type a comment in here to describe what this piece of code is going to do. I'm going to say get object ID and set unique group name. Okay. So the first part that we need to write is the object ID. We need to retrieve it. So we can do that from the current primitive, the first primitive that's coming into this attribute wrangle. Because we do have it available here, we can just grab it from primitive 0 and that should work. So let's say integer attribute object ID equals the primitive attribute from the first input, input 0. Then we need to grab the object ID attribute. And then finally, let's add the last argument to grab it from primitive 0 right here. Okay. So with this, we should now be retrieving our current primitive number, this one, for this loop. Then next what I want to do is take a string and add this number to it, and then assign that as a group name. So first let's create the string. Let's say string group name equals, and then we can use the sprintf function. Now we already used the printf function before when we were looking at the attribute wrangles earlier. We could use that to print things to the console. Well, we can also use sprintf with an s in front of it. And what this will do is it will simply output it to the attribute in front of it. So inside quotation marks, I'm going to type collision geo simple underscore. And then in order to add the number to it, we need to add a marker for that. You can use for that the percentage symbol and D. So percentage D will allow you to add an integer component to this string. Then for every single one of these markers that you add, you need to add a comma and then what you want to add inside of that data, right? So in this case, we want to place the object ID there. If we do that, and we terminate this line, then now what this should be doing is basically create a new string that starts with this and then concats onto it this part here, the object ID. So if we want to test it out, we can do that, but I'd rather just write it to a group and then we can immediately see if it works or not. So let's do that actually next. Let's say set the group name to the current primitive. All right. Now in this case we are actually still running over points, so let's switch that over first. Set this to primitives, and then in here let's add a new function called set prim group. And set prim group will allow us to set a primitive group and a value on or off to a particular primitive. So in this case, what we want to do is set a primitive group on input 0. That's the main input. That's what you normally set it on anyway. And then next, we need to provide the actual group name that we want this to set. Now we already have it here inside of this string local variable called group name. So we can just grab that and put it in here. That will work. Then we need to tell it which primitive to write this group to, which is going to be our primitive number, right? So we can say primnum in this case. And then we need to tell it if it either needs to be on or off. So basically set the group value. Well, we want it to turn on, so we type 1. And then finally, we need to tell it in an actual string value if it should set or toggle the value. So in this case, we wanted to set the value. So with that, if we type this and we apply that, now it should have created a group on our mesh for every one of our primitives with the number of this particular loop, which is exactly what we want. Now it's creating a collision geo, not a rendered collision geo. So we do need to combine this back with our original model for it to work. So let's grab a merge node here. Plug that together. I'm just going to call this one merge collision simple. Okay. And then what I would like to do is just copy this and also apply it for the UCX collision as well. So we can just copy this setup here. Put it over here on the right. Let me just make a little bit of space. And I'm going to change inside of the code of this second wrangle node, simple to UCX. Like that. So this one will create UCX and then the number. Now we need to decide which collision we want to use. So up here, we already have our switch. Go ahead and grab this one. So Unreal Collision for FBX. Copy that. Paste it down below here. And then just snip this line with Y. Okay. And then we need to go ahead and plug this up. So let's grab our main line here, which is basically when we do nothing with this data. And I want to add a second copy of this line and plug it in for the second entry as well, because this is for the first and second collision option here, no collision and FBX sourced complex collision. So if that's applied, I don't want anything to happen to this data. It can run through the loop, but nothing will happen to it. And then after that, we need to set the third entry to our simple collision and the fourth one to the UCX collision type. Now I'm just going to make sure these are named correctly. So I'm going to name this one UCX and this one as well. Okay, so with that, now we should have a basic system here that can create a unique group for every single one of our meshes in case this is enabled. So this will deal with the first type of multiple collisions, basically the one that deals with this one here, the collision geo, and then whatever type you have with a number. So we have multiple collisions per object. But then the next one I want to set up is this one here, where we have the rendered collision geo, UCX and simple, and this will split it out into different models. It's not something I really like to do when it comes to creating models, but I do want to support it. So let's go back and let's copy this network here as it is. Paste it over to the right. And I'm just going to name these groups a bit differently. Let's change these over to rendered collision geo simple and UCX. Okay, so let's rename these ones. Grab that. And if you want, you can move them down a bit so they don't intersect with one another so much. Like so. And then in here, I'm just going to add rendered to these names. Like that. And then finally, because this is a rendered collision type, we don't want to merge these with the original geometry. So let's just get rid of that. Plug them in directly. Like so. Okay, so with that, this should now be set up properly. Now we need to go ahead and add a switch in here so we can toggle between these different states, and then finally we want to merge it back in here. So let's add a couple of null nodes over here, one for each type of collision state, right? Let's add a null node here on the left. This one's going to be for our shared collisions. Let's grab over here from the top, pull that in. This is going to be the default shared collision state. So the one that we currently have in Unreal right here. Then let's create another null node. Plug that one in. And I'm just going to move this over a little bit, so we have a bit of space. This one's going to be our multiple collisions for single meshes, like so. And then finally, here on the right, let's add a null node here for split meshes for every collision group. Like so. Okay, so let's grab these three, grab a switch, plug these together. And I'll just call this one the convex collision per object switch. Okay. So as for this part, let's also give this some null nodes just to make sure we know what everything is. The part on the left is going to be a null node called packed geometry. Okay. Then we have our no FBX here on the left. And then finally, let's set this one up for copied geometry. So when we have our copy geometry, which is entry number 4 on our props output mode, which is what this switch is linked up to, right? We can grab our 4th entry, pull that over, and plug it in. So it should be plugged in like that. Okay. And then we just need to make sure that we have everything hooked up. So let's look over here. This is plugged in. These are all plugged in. And then our convex collisions per point still need to be set. So let's grab from here our multiple collisions per object. Copy that parameter. Paste it in. That's set up now. And now we should have the ability to determine what type of collision we have. So if I switch this around, we can switch it to a rendered collision geometry, and that all works. Or we can set it to a single shared collision. Okay. We can also use simple. That all works as well. And then we have our FBX sourced complex collision over here for collision geo. And then if we set this over to instances, we won't actually see our groups because they are inside of our packed geometry and we can't read those anyway. So that's all working. I think it's time to test this out in Unreal, and then we can go ahead and wrap up this lecture because it's been long enough. Let's go up to our main output node, make sure that's rendered, save, and then let's go over to Unreal and quickly run this through a test. Let's re-import this, reload, and now you can already see we now have a collision for every single one of our objects. In this case it's a UCX convex collision, and that's because under our props right now we are using a new UCX convex collision and we have multiple collisions per object. So that's working properly. Let's also switch it over to simple collision and try that one out. And that one seems to be working too. Yes. Okay, that's good. And because these aren't actually instant, we can actually go ahead and view it in our viewport. So that's nice too. Then let's switch out the alternative mode over here. Let's go to unique object for every collision. And if we turn that on and we look at the output, then it looks like nothing has changed. But up here, we now have a lot of independent components because every single one of our meshes here has basically been output as an independent mesh. I don't like to use this option, but if you have a lot of unique meshes, then this is an option, of course. You can make sure that every one of your unique meshes is output as a unique element. And if we look inside of the asset component and we scroll down, then we have all of those down here as well. Each one assigned with its material, each one a unique model, though they do all have their offset currently located based on the pivot of the tool. So that's something to take into account, right? Anyway, let's go back and let's switch this over. Let's also test out UCX collision. That's working too. Everything's working. Let's switch it into packed instances mode next. If we do that, nothing should have changed because now our splitting system for the collision type is disabled. And we can simply turn on any of these types, like simple, and that still works. Okay. All right, so at this point, I think our main collision system is done. We have the ability to switch between different types of collisions, as well as our original instances as well. That still works, right? But at this point, you know how to create different types of collision groups, how it influences it inside of Unreal, and what it means for you when you also use packing to create FBX instances. So at this point, I think I'm actually going to close down the lecture. We've done enough in this one. And while there's a couple of housekeeping things that I still need to do, I'm going to do them in the next video, where we're going to add the remaining visualizers that we want to add for our tool, right? So we have these dots over here on the roof that indicate where objects can spawn and where they can't. And then we also have this text-based readout, which we're going to build in order to display what current state our tool is in. And that's pretty useful as well. So I'll show you how to build that. That's going to be a decidedly shorter video. But yeah, we're just going to make sure that we wrap up our current instancing and FBX chapter, and then we can move on to the next part, which is going to be the staircases and the elevators in more detail. So with that, I'd like to say thank you for watching this video. If you enjoyed it, please leave a comment or a like, and you can always come to the Discord channel. Link is in the description below if you want to actually show some of your progress. I always like to hear from you guys, so if you want to do that, feel free. And with that, thanks for watching this video, and have a good one.